Right, so RPA, photosynthesis, can you believe your luck? This one's on exam practice. I've made a video that talks through the experiment step by step. This isn't really going over exactly in minute detail how you do it. I'm assuming you already know that. It's why you did certain things and what you might need to know for an exam. So photosynthesis looks like this. It takes water and carbon dioxide and it converts it using the energy in sunlight to oxygen and glucose, but you can limit that reaction. So because photosynthesis needs certain things to happen, if you take them away, for example water, carbon dioxide or light, it can't happen. Here's a weird analogy, but I've just thought of it and I'm going to try it. Let's say I'm baking a cake, I've got all my ingredients. If someone comes along and nicks half my butter, then I can't make as many cakes anymore, because even though I've got the sugar and the flour, you've taken away one of my core ingredients, so I can't be making the cakes. And it's the same idea. If you take away the water, it can't happen as much. If you take away the carbon dioxide, the rate's going to be lower. And this experiment is looking at how light affects photosynthesis. So like I say, I've gone through this before, but just to explain a couple of things. You might keep the cut end upwards so you can make sure you can see the bubbles rising. You'd use sodium hydrogen carbonate because CO2 can limit the reaction. And I'm not interested in what CO2 can do. I'm looking at what light can do. So I've got to make sure it's got loads and loads of CO2. So the only difference I see in the rate of photosynthesis is due to the light. So I use the same volume of the same concentration, make sure it's got loads of CO2. And I might put it in a beaker of water, and I do that because it protects the plant from the heat of the lamp. We'll do a bit more on that in a second. And there's the remaining steps if you want to pause and remind yourself. So one of the most basic questions is, what are the variables? So the independent variable, the thing I'm changing is the distance between the pondweed and the lamp. That's how I'm going to control how much light the plant has. The things I'm measuring, the dependent variable, the bubbles per minute, had a stroke, and the control variable, they're all the things I'm keeping the same, so I can be certain that any difference I see is due to the light intensity. So that's the size of the pondweed, the type of pondweed, the concentration and volume of the sodium hydrogen carbonate, and the temperature, which brings us to improvements. Because a lamp can get hot, and the temperature, as we'll come to see, is important, you can use something called an LED bulb, and basically it doesn't get hot. So you're thinking, okay, you keep banging on about temperature, but why is that relevant? Because temperature can speed up or limit the rate of photosynthesis. So I need to make sure, if I have a lamp right next to the plant, I need to make sure that any change I see is because the light intensity is higher and not because it suddenly got hotter. So to make sure that it's the light intensity, you might use an LED bulb. That way you don't even need that beaker of water anymore. Now, alternatively, a couple of other things. You might miss a bubble. You know, it's not the most exciting thing in the world, so you might not be paying attention. But speaking of excitement, you could video it and then watch it back to check you got it right. Now, there's a much bigger one, is you could improve the accuracy by changing the method slightly. Because counting bubbles, if you're counting bubbles, I don't want to know you. But if you are, however, interested in finding out the volume of oxygen, you're onto a winner. So how do we do that? How, instead of counting, can we find out the volume of oxygen and improve the accuracy? Now, I've had to draw this out on PowerPoint, and you've probably got a life, so you haven't ever tried to do that yourself. But I'll tell you now, it's difficult. So this looks a bit budget. So it looks like this. Let me talk you through it. So here I've got my pondweed in my sodium hydrogen carbonate. Here I've got something called a bung, not a bong, but a bung. It's kind of like a cork. And through that bung, connecting my pondweed, is this thing here. It's connected to a gas syringe. And that's going to let me measure the volume of oxygen. And here's how. And here's where the production value goes downhill. So my pondweed, it photosynthesizes. Here's a couple of bubbles of oxygen. They've got nowhere they can go, right? Because it's all contained. And as the gas collects and collects, it will end up going up through this tube to the gas syringe. And as more and more and more oxygen is produced from the plant, it ends up pushing part of the syringe out. So now I've got an exact measure of volume of oxygen by how far it pushes the gas syringe. And that's more accurate because I'm not counting bubbles. Bubbles could be different sizes, for example, or I might miss a couple. So you've got your results, and I have been through this before, so I don't want to spend ages doing it, especially because I've already been banging on for about 5 minutes. But in short, the closer you are, the higher the light intensity, the faster the rate. The further away the lamp is, the lower intensity, the less bubbles, the lower the rate. So here it is again for you, just written down in case you want to pause and read it yourself. But as I say, in summary, the closer the lamp, the higher the light intensity, the faster the rate and the more bubbles. But what we haven't seen before are these kind of graphs. So you can see that at the start, as light intensity increases, the rate of photosynthesis is going up as well. So for example, there's no units on this, they've just said in units. So at 5, it's about 30, at 10, it's about 50, and at 15, it's over 60. So it's going up. But if you have a look, eventually it flattens out. The light intensity is still going up, 20 to 25 to 30, but the rate of photosynthesis doesn't budge, right? It stays at about 70. Why is that? This is one of the bigger questions. It's because light intensity is no longer the limiting factor. There's something else that's limiting it. For example, carbon dioxide. Let's go back to my weird baking thing. Say, for example, I've got flour, I've got sugar. What else do you need? Flour, sugar, butter, and I've got butter. And I'm making a cake, and someone comes along and they go, oh, here's a bit more butter, here's a bit more butter. Say, okay, great, but I can't make any more because I'm still missing the sugar, I'm still missing the flour. And it's the same idea. You can see here, I've got 5 and 10 centimeters away, but the bubbles stay the same because it's got enough light at those distances, but it's lacking something else. For example, maybe it needs more carbon dioxide. So the graph will appear to flatten out because something else now is limiting it. So hopefully you feel like you could explain why you do some of the things in the method. You could say what the variables are. You could suggest a couple of improvements, and you feel like if you had a table or graph, you'd be able to explain it away. Hope that weren't too boring. See you later on.